Hello, this will be the second part of the video on the inverse trig functions. So here we are, we just went through this table. I have a clean copy this time, so it might not look the same. So we understand that inverse sine, inverse cosine, inverse tangent, they reverse how these trig functions work. And there's this fine print about the ranges. So when we choose an angle, we need to choose it from the correct range. As I mentioned before, your rule of thumb is pick something as close as possible to 0, and if there's a tie between a positive and negative, make it positive. So with that in mind, try these on this page. Right? Hit pause and literally give them a shot. I hope you have done that. So now, inverse sine of 1/2. We're basically asking ourselves, what is the angle where when we take sine, we get 1/2? If you want to visualize a unit circle, we're saying that the y-coordinate sine is 1/2. There are basically two places on the unit circle where that happens. The one that's closest to 0 would be an angle like this. So this would be 30 degrees or pi over 6. If you're answering in degrees, make sure you're including this degree symbol. Oops. If you don't include the degree symbol, people will assume you mean radians. Now, inverse sine of 2, that means sine of some angle is 2. Well, is that possible? This is a y-coordinate on the unit circle. The very top of the unit circle is at y equals 1. There is no place where we get y equals 2 on the unit circle. So here, there's simply no answer. You could say undefined, does not exist, no answer. Anything that communicates that this doesn't exist. You could say 2 is not in the domain. Okay, inverse cosine of root 2 over 2. So here we're thinking cosine of some angle is equal to root 2 over 2. That's the one that happens with these in-between angles. It could be 45 degrees or pi over 4 up here. Could be negative 45 degrees or negative pi over 4 down here. And remember, part of the rule is for inverse cosine, we're picking something between 0 and pi. So it's going to be these positive ones. Inverse cosine of negative 1, we're thinking that cosine of some angle is negative 1. That means the x-coordinate is negative 1. That happens at the leftmost part of the unit circle, and the answer here would be pi. Inverse tangent of 0 means the tangent of some angle is 0. Right? Tangent is sine over cosine. A fraction is 0 when the top is 0. So basically, this means that we're getting the sine of 0, and you can check that an angle of 0 does that. Right? Tangent of 0 degrees or 0 radians really is 0. And then inverse tangent of root 3. Kind of the trick when you see the root 3's is to maybe recreate this. Root 3 over 2 is actually, root 3 is actually root 3 over 2 divided by 1/2. So you could sort of think, can I think of an example where this is cosine of theta up here? Oops, I have not actually writing. Can I think of an example where this is cosine of theta up here and this is sine of theta here? So hopefully you can think, this familiar angle, pi over 6 or 30 degrees, has exactly that combination I want. Oh, yikes, sorry. Let's be careful. I am going crazy. Maybe you noticed something was wrong. Tangent, of course, is sine over cosine. So we want sine to be root 3 over 2 and cosine to be 1/2. That's this angle. Pi over 3 or 60 degrees. Sorry about that. I'm going too fast. So if you know your basic trig, you can do these backwards. It's a little bit slower to do it backwards, but all the relevant information is something you know. So now that we have, so what if we have something like cosine of theta equals 0.41? Right? Cosine measures the x-coordinate on the unit circle. Let me try to draw a better unit circle this time. Okay, something like so. Good enough. So here is where x is equal to 1. Here is where x is equal to 0. Somewhere right around here would be where x is equal to 0.41. There's a point on the unit circle there. And there certainly is an angle that would work out like that. And if we think about what all of these things mean, there absolutely is an angle that satisfies that equation. The problem is, it's not something we know off the top of our head. 1/2 is a number that comes up a lot. Root 2 over 2 is a number that comes up a lot. Root 3 over 2 is a number that comes up a lot. But 0.41, we're just not familiar with this. And this is okay. This is where our calculator will come in. So we know if cosine of theta is 0.41, we can sort of rearrange that and say, oh, well, that means inverse cosine of 0.41 gives us that angle. And this is something you can literally just type into your calculator. So on your calculator, obviously you can't see my calculator. Inverse cosine is in the trig menu. Right? You've probably already done some of this with sine and cosine and tangent. If you go to on your calculator, you type that trig button next to the 7, and you'll see various options. And one of them is cosine inverse. It's below cosine. So you type cosine inverse. Or you don't type it. You can just click on cosine inverse, and then just in the parentheses put in 0.41. And your calculator, my calculator spits out, and I'll round this to 3 decimal places. Let's do 4 decimal places. 1.1483. So that's telling me the angle. And just from my rough picture here, I know this picture is not perfect, but it's not crazy. Can I change that? I think I want to change the tail on this. Yeah, I'll fix that later. So I know that I have an angle that looks something like what I've drawn in this picture. That's not 1.1 degrees. This is 1.143 radians. Maybe when I typed that in, it wasn't even clear to me if I was thinking that. If you look in the upper right of your calculator screen, you should see something that says either RAD for radians or DEG for degrees. Right? You can change that by going over to it and highlighting it. If you go over to that and click on it, I'm doing that on my calculator, which you can't see right now. There's a way to change that. I will show you in class how to do that. But just be aware. Right? That's the most important thing. Your calculator is already programmed to do things in radians or do things in degrees. That is changeable if you like. But when you're getting an answer like this, pause and say, did I just get an answer in degrees or did I just get an answer in radians? You can convert it later on if you need to. So just a couple of things to keep in mind. The way we indicate these inverses is with a superscript of -1. Superscripts in math usually mean exponents. They usually mean powers. This is an exception. In this context, the superscript of -1 is not an exponent, it just means inverse. So you have to pay attention to context. If I show you something like this, the number 4 to the -1 power, you can say, oh, this is an exponent. That superscript of -1 is an exponent. Raising things to negative powers gives me fractions. But over here, you have to use the context. When you see this next to a trig function, you need to just pause for a second and say, I'm not raising a number to the -1 power. I am doing this with trig, and this just has a special meaning of inverse. It does not mean an exponent. We are not taking a fraction here. We are doing it backwards. If we wanted to express this, we actually have a name for this already, which is cosecant. So when you want to do 1 over a trig thing, that's where we say, oh, 1 over sine is called cosecant. 1 over cosine is called secant. 1 over tangent is called cotangent. We already have a word for that, and we're not going to use the negative one. Some older books use the prefix arc instead of the superscript, and sometimes people will pronounce this with an arc. So if ever you see typed out or you hear someone say something like arctan is just another name for inverse tangent. Arcsine is another name for inverse sine. Arccosine is another name for inverse cosine. I won't use it too much, but you may hear it or see it someplace else. And the calculator is a great tool, but pay attention to the mode. If you are trying to give an answer in degrees and your calculator is in radians, be aware of that so you're not writing down something dumb. Okay, so let's see what we got here. By combining algebra, arithmetic, and understanding of inverse trig functions and the power of the calculator, we can now solve some pretty complicated problems. So here's a word problem. A lot of natural phenomena vary in a wave pattern over the course of time. And very often we can use trig functions to understand those wave patterns. So here's an example. In a certain city, temperature fluctuates over the course of the day following a wave pattern. If T measures the number of hours since midnight, then the temperature in degrees Celsius is given by this formula that I have written down. And here's a graph. So what we're noticing here is basically the lowest temperature is somewhere around 16 degrees Celsius. The highest temperature is somewhere around 32 degrees Celsius. And over the course of the day, the temperature goes up, the temperature goes down after a full, and you'll notice that's a full 24 hours. That's 25, it's a 24-hour cycle. Temperature goes up, temperature goes down. So this is not uncommon. Things like temperature, things like amount of daylight, a lot of these things like measuring the tides, a lot of these change. Oh, it gets bigger, it gets smaller, it gets bigger, it gets smaller, it goes up, it goes down. And it does so in a way where if we were to graph it out over time, it looks like some version of the graph of sine or the graph of cosine. So we're just taking it as a given that this is the formula that explains this. And here, there's trig that's done in radians. So here's the question. Identify a time of day when the temperature is 25 degrees Celsius. Now from the graph, we could already come up with a decent estimate, right? Here, it looks like it crosses 25 around T equals 6.5, which would be around 6:30 a.m. We're measuring hours since midnight. Looks like it happens again here around T equals 17.5, which would be around 5:30 p.m. So we want to solve for at least one of those. Well, let's use our formula. So I want to know when is the temperature. This whole thing is the formula for the temperature. Even though I'll ultimately use my calculator, I want to write out a lot of this. I want to know when is that temperature equal to 25. I'm going to solve this for time, right? A when question means what time, right? Identify a time of day. So we're going to solve for T. All right, so let's do a little algebra. I can subtract 24 from each side. If I subtract 24 from each side, I just get 1 over here. Let's get rid of that -8. I want to get the trig all by itself. So I would have cosine of pi over 12t is equal to -1/8. And this is what's important. Once the trig is all by itself, right, there's no numbers in front of it. Cosine of something is equal to a number. This is where I can use inverse trig. So this whole thing here, right, that thing in yellow, cosine of the thing in yellow is -1/8. That's equivalent to saying that inverse cosine of -1/8 is pi over 12t. Right? I am just switching the relationship. Let's highlight these to see that. Right? Even if you're having trouble thinking of this in terms of angles or anything like that, because this isn't really about angles anymore, it's about temperature. we know that inverse cosine simply reverses the relationship of cosine. So over here we have cosine of the yellow thing gives me the pink thing. If I reverse that, it means inverse cosine of the pink thing gives me the yellow thing. Cosine starts with yellow and gives me pink. Inverse cosine starts with pink and gives me yellow. It's the same relationship but backwards. And what's great is now I can just put this in my calculator. So on my calculator, and I'm going to make sure I'm in radian mode. The problem told me that very explicitly. So inverse cosine of -1/8. I put that in my calculator, and I get 1.69612. 5 decimal places should probably be fine. Equals pi over 12t. So now to figure out t, I can take 1.69612, which is already on my calculator, and divide it by pi over 12. So I'll just do divide, and then in parentheses, so that the calculator understands, pi over 12. And what I'm getting here is that t is approximately 6.4787. So this is solving for t, but it might feel a little unsatisfying, right? Identify a time of day. And if you're like me, this sounds very awkward. If I say, hey, what time do you wake up? And you just say something like 6.4787 hours after midnight. That's not really how people talk. So we really want to convert this to a normal time. So what we could do is we could say, all right, this definitely means 6 a.m. And then this is a fraction of an hour. Oh, yikes, that's why, oops, sorry. So this means 6 a.m. And then this represents some fraction of an hour. And usually fractions of an hour we express in minutes. So what you could do is you could say, all right, that part times 60 would tell me how many minutes, right? What fraction of 60 minutes do I have there? So this will give us an answer rounded to a minute. That'll sound a lot more normal. So if I do 0.4787 times 60, that comes out to about 28.7. Let's round that to 29. So our answer here, the answer that sounds most like a normal human answering a question, would be, oh, it hits the temperature of 25 degrees Celsius at 6:29 a.m. But we need to do a little bit of work to get it from this decimal thing to normal time. But just to recap, we had a phenomenon where a function involving trig described how something changed. We wanted to know when it had a certain value, so we just set up this equation, did a little bit of algebra, got it to the point where the trig was all by itself, cosine of something equals, sine of something equals, tangent of something equals. Then we can do the inverse trig to rearrange, and then we just use our calculator to finish. So you'll probably have some more problems like this on your homework, where you're seeing how you can use an understanding of inverse trig in your calculator to answer questions you could never do in your head. Okay, that is the end of this video.